let's take a few minutes to talk about how we would find the x and y intercepts. So for a linear equation, where does it cut the x-axis and where does it cut the y-axis? Now you can see my y-axis, which I've colored here, is the one that runs vertically. And here's the important point. Everywhere along that axis, the x value is always 0. Like it doesn't matter where I am. I could be up here at, I don't know, let's say up at 6. The y value is 6, but the x-axis is always 0. Here, the y value is 2, but the x value is still 0. All along here, the x value is always 0. And it goes the same in the other direction. So for the x-axis, along here, the y value is always 0. It never rises, it never falls beyond a y value of 0. That is the critical thing to help us proceed with what we're about to do. Here's my equation. We are asked in this example to find the x and the y intercepts for y equals 2x plus 3. Now, if you remember from previous work, the y-intercept should be nice and easy. It's just the one when x equals 0. In other words, what it should be, looking at my equation here, because it's written in the gradient intercept form of y equals mx plus b, we know that this little bit is the y-intercept. So it should be plus 3, but let's check. Now, we said that everywhere along the y-axis, x equals 0. So if I substitute x equals 0 into this equation, I should get a value of 3. Alright, so far so good. Positive 3, that's my y-intercept right there at the point 0, 3. Now, finding the x-intercept, in other words, where does my linear equation cut across this x-axis? Well, I'm going to put in a y value of 0, because remember we said along the x-axis, the y value is always 0. So wherever it cuts along here, the x value is going to be 0. Sorry, the y value is going to be 0. So I'm going to substitute y equals 0. Now, hopefully looking at that, you can see there's only the one unknown, and I can solve for x, okay? If I can find a value for x, problem solved. So now I'm just going to use my algebra skills to get rid of plus 3. The opposite is take 3 from both sides, which gives me minus 3 equals 2x. The opposite of timesing something by 2 is divide by 2, which means I can cancel them out. And now I have an x value of negative 3, 2. So I can go along my x-axis till I find the point negative 3, 2, which happens to be right there. And that is my x-intercept. I've got what I need, 2 points. I've found the x and the y-intercepts here, which is 2 points. All I need to draw a line. That, in fact, is the line. Y equals 2x plus 3. And there is my y-intercepts. Now, if I wanted to, I could just check that is the y-intercept here in my gradient intercept form. And I can see that the gradient, if I come across 1, it goes up 2. So I should have a gradient of 2, which is exactly what I've got which I look at when I look at the coefficient of x. So y equals mx plus b, remember from a previous video. Good job, we have found the x and y intercepts.